This video is going to take you through the 5-1 warm-up and then the 5-2 notes. So with number 1, it starts by asking you to graph a triangle. So we're going to insert a coordinate grid so we can do this accurately. And we're going to plot A, which is 0, 6. B, which is -4, -1. And C, which is 4, -1. And connect that as best you can. And it wants you to classify it by its sides. So the easiest part to find the side length would be BC because it's a horizontal. So if I just counted from -4 to +4, that side is 8. And then to get the other two side lengths, I'm going to have to use the distance formula. So to get AC, I would do the square root of, this one's 4, -1, and 0, 6. So 4 minus 0 squared plus -1 minus 6 squared. I get the square root of 4 squared plus -7 squared. Square root of 16 plus 49, which is the square root of 65. Because I'm just comparing these two, I don't have to simplify that, but obviously if I was giving that answer as the side lengths, I would then check to see if that can be simplified. Okay, but now I want to find AB. So now I'm using -4, -1, and 0, 6. So I get the square root of -4 minus 0 squared plus -1 minus 6 squared. Square root of -4 squared plus -7 squared. Square root of 16 plus 49 again, which is square root 65. So because these are the same and the other side is 8, I would classify this as an isosceles triangle. Then it says determine if it's a right triangle. So if it was a right triangle, the lines, you could either use the Pythagorean theorem or you could compare the slopes of the lines. So if I were to find the slope of AC, it would be y2 minus y1 over x2 minus x1, or -1 minus 6 over 4 minus 0, which is -7/4. The slope of AB would be -1 minus 6 over -4 minus 0, -7 over -4. Those are opposites but not reciprocals. And then if I were to find the slope of this horizontal line, it would be 0 because horizontal lines have slope that are 0. So this is not a right triangle either. Number 2 says find X and then classify the triangle by its angles. So I know the sum of these 3 angles add up to 180. So I'm going to do 3x plus 20 plus 50 plus 2x equals 180. Combine my like terms. So 3x plus 2x is 5x plus 20 plus 50, which is 70, equals 180. Subtract the 70 from both sides. 5x is 110. Divide both sides by 5. And x is 22. So that's x, but I still need to know the actual angle measurements in order to classify it. 2 times 22 is 44. That makes 50 and 44 that are both acute. And then 3 times 22 plus 20 would be 66 plus 20, or 86. And all 3 of those are acute. So this would be an acute triangle. Number 3 says find the measure of the exterior angle shown. So we know that the exterior angle equals the sum of the 2 remote interior or non-adjacent interior. So x plus 72 would equal 2x plus 40. Subtract the x. 72 equals x plus 40. Subtract the 40. And x is 32. But it wants the exterior angle, so we're going to take that 32 and add 72 to it, and I get 104 degrees, which is what this is looking for. Number 4 says to find the measures of x and y. So there's a couple different ways to look at this. If you were to use the triangle here on the right, that top angle is 32, bottom right is 50. Add those together, I get 82, subtract it from 180, and I get 98, which is going to be this angle in here. And then 98 and 100, and the x on the outside are linear pairs, so I would subtract that from 180 and I get 82. You could have also used that x is the remote exterior angle of that triangle, so you could add 32 and 50 to get that one's 82. Then you can use this triangle here, and knowing that this is a right angle and this is 50, the right angle tells you the other two angles would be complementary, which means the angle here on the left is 40. And then I can use this smaller triangle, and I can do 40 plus 82, which is 122, and subtract that from 180 to get that top angle, which would be 58 degrees. So this one here would be 58 degrees. Or once I know this is 98, these two would have to add up to 98 degrees. So you can also subtract the 40. So there's a couple different ways to look at it, but either way you should get x is 82 degrees and y is 58. Okay, so 5.2 is talking about congruent polygons. So we're going to deal with some definitions here and then figure out how to find the congruent sides and the congruent angles in pairs. The definition of congruent figures are two figures that have the same size and shape. In order to prove that two polygons are congruent, all the pairs of corresponding parts of one figure have to be congruent to the corresponding parts of the other figure, which means that if you have two, in this case, triangles that are congruent, that each angle has a congruent partner. So right now from this diagram, we can use the single scoop with the single scoop. Angle A would be congruent to angle F. The double would be B, would be congruent to angle E, and the triple would be angle C is congruent to angle D. So not only are all the angles congruent in pairs, but the sides are too. So this single tick mark matches this single tick mark, which means AB is congruent to FE. The double on the bottom would be congruent to the double, which is AC is congruent to FD. And the triple would be that BC is congruent to ED. You'll also see this given from what's called a congruency statement, or a statement of congruence, which would say triangle ABC is congruent to triangle FED. And when you get just the statement and not the markings on the triangle, the order of the letters is important. So A goes with F, B goes with C, B goes with E, C goes with D, and then the angles of the sides you would partner up to. First two, AB would go with FE, BC would go with ED, and first and last, AC would go with first and last FD. So you'll either get a diagram that's marked like this to know that they're congruent, or you'll get given a congruent statement like that one on the bottom there, and you'll match up the letters using the order of the letters provided. Third angles theorem says if two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent. So this is kind of common sense. Like if I know that this is 50 and this is 100, then this is 50 and this is 100, and all three have to add up to 180, I know it leaves 30 and 30 for the last ones. What this theorem helps with is that you don't actually need to know any measures of the angles. You just need to know that in pairs they are congruent. So if the two angles like this, if A and D are congruent and B and E are congruent, then you conclude that C and F are congruent, and the reason is the third angles theorem. All right, properties of congruent triangles. So the same properties that we used on segments and angles are also applicable to triangles. The reflexive property of congruent triangles says that for any triangle, ABC is congruent to itself. So triangle ABC would be congruent to triangle ABC. Symmetric remember we just reversed the order here. So if ABC is congruent to DEF, then DEF is congruent to ABC. And transitive is your if and then statement. If ABC is equal to DEF or congruent to DEF and DEF is congruent to JKL, then I can bridge the gap of the ones that don't, so eliminate what repeats, and I can get ABC is congruent to JKL. All right, example 1. Complete with always, sometimes, or never. So I'll give you a couple minutes, and then we'll go over it. Okay, so looking at number 1, it says an acute triangle is blank congruent to an obtuse triangle. So in order for two triangles to be congruent, their angles have to match up. And if you have an acute, it means all are acute. And obtuse, one has to be obtuse, which means these can never be congruent. Number 2 says a polygon is blank congruent to itself. And this is always. Number 3, a right triangle is blank congruent to another right triangle. And this is sometimes. So they might be the same right triangle, but not necessarily. Only one angle would have to overlap. 4 says if ABC is congruent to XYZ, then A is blank congruent to Y. So A, by definition, would always be congruent to X, but it can be congruent to Y in, say, like an isosceles triangle. So this is sometimes. Or in an equiangular triangle, all of them would be the same. And 5, if ABC is congruent to XYZ, A is always congruent to X. Example 2 says in the diagram, ABCD is congruent to FGHK. Find the value of X and find the value of Y. So if these are congruent, then the corresponding sides match. So AB matches FG, which means these two are congruent. And 3x minus 6 would equal 9. Solving for x, I'd add the 6 and divide by 3. And x is 5. And then the angles, angle K is where 4x plus 2y is. Angle K matches angle D, which would be 44. So 4x plus 2y equals 44. And we already know what x is. It's 5. So 4 times 5 plus 2y would equal 44. 20 plus 2y would equal 44. Subtract the 20. 2y would equal 24. Divide by 2. And y is 12. Example 3 says Maggie took a piece of fabric, STUV, shown in the diagram, and cut it on a diagonal to make a scarf for her and her friend. Are the two pieces the same size and shape? Explain. So the question is, are these two triangles congruent? And in order for them to be congruent, all three sides would have to match the other three sides, and all three angles would have to match the other three angles. So I know that one pair of sides, this single tick and this tick mark match, that's one pair. Two pairs of sides because of the double tick marks. And then this side is part of both triangles. and SU would equal SU, and that's reflexive. So that gives me all 3 side lengths. Now I just need all 3 angles. And that's a little trickier. But because these are perpendicular to the same transversal, I know these are parallel lines. And if I use this as the transversal, then I know angle 2 is congruent to angle 3. And that's because of the alternate interior angles theorem. I know angle V is congruent to angle T because they're both right angles. And then I can either use the other pair of parallel sides with the transversal to show 1 is congruent to 4, or I can say 1 is equal to 4, third angles theorem. And then once I know that, the triangles are congruent, and that would be the definition of congruent polygons. If all 3 pairs of angles are congruent and all 3 pairs of sides. So we will eventually get into proofs on these, but this one just said loosely explain. And last question is that proof. So given SV is congruent to RV, TV is congruent to WV, and ST is congruent to RW, and angle T is congruent to angle W, prove the triangles are congruent. So my given is the 3 pairs of sides and 1 pair of angles, which means I still need 2 other pairs of angles. Remember that we can use anything that we've used up to this point in geometry, which means we can actually use the vertical angles. And I would, because I have to use 3 letters, I would say TVS is congruent to angle WVR. And that's, step 2, the vertical angles theorem. Then I can say the third angles theorem, angle TSV, or you can actually use just 1 letter that time because S is not shared. S would be congruent to R, third angles theorem. And then I can say that the triangles are congruent. And that is the definition of congruent. And you can say polygons or you can say triangle. Doesn't matter there. But that would prove those 2 triangles are congruent. Okay, that wraps up the notes for today. Please make sure you take a moment to turn in the 5.1 warm-up and 5.2 notes in one document, and then use the remaining time to work on the 5.2 big ideas homework. Have a great weekend. I'll see you guys soon.